Hey everyone! Today we're going to explore the topic of medians of triangles. Let's get started. Let's start by defining what a median of a triangle is. A median is a segment that joins a vertex of the triangle to the midpoint of the opposite side. These three examples here illustrate a median of a triangle. In this first triangle, ABC, segment BD is a median of this triangle because it connects one of the vertices to the midpoint of the opposite side. Remember, a midpoint is the point such that it breaks a segment up into two equal parts, as indicated by the same amount of slashes. The same thing can be illustrated in the next triangle, just to give you a different angle and a different point of view. Notice we have triangle STR such that segment TU is a median because it joins one of the vertices to the midpoint of the opposite side. And again, likewise, for triangle XYZ, median ZW connects the midpoint of one side and the vertex. Let's use this definition of a median to answer this first example. Example 1 states, in triangle EFG, segment FN is a median. Let's find the length of EN if EG's length is 11. So remember, we'd like to indicate any of the given information with slashes and arcs in our diagram. Since they told us that FN is a median, then we know that the length of EN is equal to the length of NG. But they told us that the length of EG is 11 total. So, if we want to find out what EN is, we could either simply cut 11 in half or indicate that EN is equal to X and NG is equal to X. That way, we can actually write an equation. So, X plus X are two parts of our segment set equal to our whole. Combine like terms, we get that 2x is equal to 11. Therefore, divide both sides by 2, and we get that x is equal to 5.5. Therefore, the length of EN is equal to 5.5 units. Let's try example 2. Again, utilizing our idea of a median. It states that in triangle RST, segment RP and SQ are medians. If RQ is equal to 7x minus 11, SP equal to 5x minus 4, and QT equal to 6x plus 9, then let's find the length of PT. So here we have an example which will require a multi-step process. Remember, when possible, let's indicate the given information in the given diagram. Now, since RP is a median, we know that the length of SP will be equal to the length of PT. Likewise, since SQ is a median, it's going to intersect segment RT at its midpoint. Therefore, RQ is equal to QT. Now, they told us the length of RQ was equal to 7x minus 1. SP was equal to 5x minus 4. QT was equal to 6x plus 9. And we want to find out what PT is. Now that I've indicated all of my given information on the diagram, I can easily set up my required equation. So let's set the length of RQ equal to the length of QT. Here we go. So I have that 7x minus 1 is equal to 6x plus 9. Let's solve for x by isolating our variable. I'll subtract 6x from both sides while adding 1 to both sides. This way, I've canceled my variables on the right side, I've canceled my numbers from the left side, and I end up with 7x minus 6x for a grand total of just x, set equal to 9 plus 1, which is equal to 10. Now that I have my value of x, I can finish the question. In order to find PT, I want to find the length of SP. So let's just indicate here that the length of PT is equal to SP, therefore it is equal to 5x minus 4. And when we plug 10 in for x, we get that 5 times 10 minus 4 will be the length of PT. 5 times 10 is 50, minus 4 will give us 46 total. Therefore, 46 is the length of segment PT. Before we move on to the next concept, let's first define a concurrent and the term centroid. Concurrent means when 3 or more lines or segments meet at the same point. So let's look at this diagram right here to better understand what concurrent means. So in this diagram, we would say that segment JR, segment KP, and segment QM are concurrent at point X. A centroid is a special type of concurrent point. A centroid is a point where the 3 medians of a triangle meet. So in our diagram here, not only are segments JR, KP, and MQ concurrent at point X, but also, if they are medians, then we would say that this point of concurrency is a centroid. Now let's consider Theorem 6.1, which states the length of the segment from the vertex to the centroid is twice the length of the segment from the centroid to the midpoint. In other words, all of the medians intersect each other at a 2-to-1 ratio. So let's look at all of our examples that we have right here. This first one is triangle ABC. If we're given that AD, CF, and BE are all medians and intersect at centroid X, then the length AX given as 26 should be twice the length of XD. Therefore, we could conclude that XD is 13. Likewise, in the next triangle, ABC again. However, we're looking at median BE. Since all of these medians intersect at centroid X, the length BX is 20 and should be twice the length of XE, which is 10. Looking at the third median within triangle ABC, centroid X breaks median CF up into a 2-to-1 ratio, such that CX is twice the length of XF. Let's apply this theorem in our next example. Example 3 states that in triangle XYZ, XP, ZN, and YM are medians. So let's indicate in the diagram that NX is equal to NY, YP is equal to PZ, and XM is equal to MZ. Now it states that we want to find out what ZQ is if QN is equal to 5. Now, looking at the diagram, ZN is a median, and remember, our point of concurrency, which in this case is Q, is our centroid, and the centroid breaks each median up into a 2-to-1 ratio. So since they gave us QN, let's indicate that here in this diagram as 5. Well, if we're trying to find out what the length of ZQ is, we know that that should be double the length of QN. Therefore, ZQ is equal to 10 units. Now, let's consider the second part of example 3. Here we have segment XP has a length of 10.5. Let's indicate that in our diagram to know which side of our median we're talking about here. So XP is actually the entire median itself. That length is given by 10.5. If they're asking us what QP is, let's keep in mind that QP is half the length of XQ, or in other words, XQ is twice the length of QP. Therefore, if QP is unknown, let's just indicate that by X, and therefore, since XQ should be double of that, we'll indicate that by 2x. Therefore, we get an equation to be 2x plus x is equal to 10.5. Let's combine like terms. We get that 3x is equal to 10.5. And dividing both sides by 3, we get that x is equal to 3.5. Now let's consider our last example. Example 4 states that in triangle ABC, CD, BF, and AE are all medians. In part A, if the length of CG is 14 So that's this part of my median. And I'll indicate that in my diagram. What is the length of DG? Again, since our medians all intersect at this point of concurrency called a centroid, it breaks our medians up in a 2-to-1 ratio. Therefore, we know that CG is twice the length of DG. Therefore, simply cut CG in half, and we get that DG has a length of 7. Now let's consider part B. Let's find the measure of BF if GF is given as 6.8. So here we have to remember that if I mark my diagram, my median is broken up into a 2-to-1 ratio. BF is the entire median, and this is what I want to find. So I'll mark that as X. Let's keep in mind, since BG is the longer portion of my median, I want to double GF to get the length of BG. So BG is equal to 2 times 6.8. Without reaching for my calculator, 2 times 8 is 16, carry the 1. 2 times 6 is 12, add the 1 for 13, and I have a total of 1 decimal place. So the length of BG is equal to 13.6. However, they were asking us for the length of BF. Since BF is equal to GF plus BG, and we know both of those lengths to be 6.8 plus 13.6, we get that BF is equal to 20.4. This concludes our lesson, Introduction to Medians of Triangles.
Made with Doodlecast Pro.